Hello and welcome to Computer Science 30S. This is the Liberty Basic Unit, Lesson 5, the bubble and selection sort. So you might remember the bubble sort from previously. When we did Scratch, recall that the bubble sort looks through the array one element at a time and switches elements that are not in the correct order. And in this fashion, the highest or the lowest value, depending on how you've got it set up, is bubbled to the top or the bottom. And you might remember an animated GIF that looked like this. It doesn't seem to want to play right now, but it would look like that, and it bubbles the highest element to the top. So you hopefully should remember that from Scratch. Here's the BYOB code for a bubble sort. So you might remember that we set the pass to 0, we set the number of swaps to 0, and we keep repeating until the pass is greater than 0 and the swaps is equal to 0. In other words, we repeat until we've gone through the whole thing and we haven't had to do any swaps, and that means it must be in order. So we set the item to 0, change the pass by 1, set the swaps to 0, and then we go to the length of the data minus 1. And why do we do minus 1? It's because the last one has been bubbled through already. Change the item by 1. And if the item plus 1, if the next one of the data is less than the current one, then you're going to do the switch. And these 3 lines here do the switch, set the value to item 1. So value is just a temporary 1 here, to the next value in the list of the data, replace the next one with the current one, and then replace the current one with the temporary one. So these 3 lines here just do that switcheroo, change the number of swaps by 1. And we repeat that until we get to the end of the data, and then we reset everything and then go through one more time. You should remember that from lesson 4 or 5, I think it was, in the Scratch program. So what I'd like you to do now is take a few moments and try to convert this into a Liberty Basic program. So I'll encourage you to pause the video at this time, take a few minutes, and then I'll show you the solution. Okay, what you should do is you should use this code to get you started. You'll create an array with 20 random numbers in it to be sorted, and this is sort of a base one here. So I dimension my array to 20, and I print the unsorted array. It looks like this. I set up a loop, a for next loop, for index equals 1 to 20. And I simply throw a random number between 1 and 100, and I put it in the current value. Notice the comment that I put here to help you. And I'm simply going to print it. And once I've done that, then I'm going to say the sorted array looks like this, and I've got a dummy input just to slow things down. And then you need to enter your sorting code right here. Okay, so let's see how that looks in Liberty Basic. And there's the unsorted array. And when I hit enter, I should get the sorted array. Currently, I'm not getting a sorted array because I haven't sorted yet. So you need to enter the code in between here. Okay, if you haven't tried that, go ahead and try that again. All right, so hopefully you've had a chance to try that. Here's the actual solution here. So we're going to print the sorted array looks like this. We're going to set pass equals 0, swap equal to 0, and we're going to use a do until, just like we did before. Set my item equal to 0, pass equals pass plus 1, swaps is equal to 0. This should likely be swap, not swapsa, because I called it swap there. And for x equals 1 to 19, I can do this because I know that this particular array is exactly 20 long. Item equals item plus 1. I'll go to the next item in the list. So if the next one is less than the current one, then I do the switcheroo, this whole little bit right here. I'm going to comment this, switch elements. Doesn't take very long to comment. And then I change my swaps by 1. I do my end if, next x, and I'm going to loop this until the pass is greater than 0 and the swaps equal 0. Really not any different than the Scratch program. The only real difference is that the until is at the bottom of the loop instead of at the top. So not a whole lot of difference. If you didn't get that, go ahead and take a few minutes and type that in, and then we'll move on. All right, I would encourage you to save that as the bubble sort. If you had some issues, I will include that code in the resource folder as well in Schoology. Now here's another type of sort. It's called a selection sort. It's a little bit more efficient. The bubble sort is in fact the most inefficient type of sorting that there is. I'm going to show you an animation here about the selection sort. Okay, so this website here just shows a whole bunch of different sorts. You can see all these different ones here. And this is the bubble sort. And let's find the selection sort right here. And here's the algorithm and some of the values, some of the references here for this particular sort. So in a random one here, I'm just going to run it, and you can see what it's doing. Watch this one here. Remember, this is called the selection sort because it's making a selection. You might be able to figure out what's going on in this particular array here that was reversed from biggest to smallest. So tell me, what is the logic? What seems to be the logic behind this? Can you spot it? Okay, well, hopefully, let's try this again. You can see that when I randomize my array once again, let's go back to the selection. Let's look at the bubble here, first of all. Let's look at the bubble. The bubble sort goes through, and it's swapping different ones that are side by side and putting them in the correct order, and the smallest one always bubbles its way to the top here. If I go back to the selection sort, and randomize it, you can see here that what it does is that it looks for the smallest one in the entire array and it puts it in the correct order. And then it looks for the next smallest one and puts it in the correct spot. And then for the next smallest one, it puts it in the correct spot. So it does quite a bit of running here. Again, it's not a very efficient sort, but it's a different type of sort. All right, so once again, the selection sort, what it does is it looks for the smallest value in the array and puts it in the very first spot. Let's see if we can actually code that. Let's look at the algorithm here. The algorithm divides the input list into two parts: the sub list of items that are already sorted, which is built up from left to right or top to bottom at the front or left of the list, and the sub list of items remaining to be sorted that occupy the rest of the list. Initially, the sorted sub list is empty, and the unsorted sub list is the entire input list. The algorithm proceeds by finding the smallest, or in some cases the largest, depending on what you're trying to do, element in the unsorted sublist and exchanging it with the leftmost unsorted element, putting it in its sorted order, and moving the sublist boundaries one element to the right. A bunch of mumbo jumbo. Let me show you an example. Here's an example of the sort algorithm sorting 5 elements. So we have 64, 25, 12, 22, and 11. So it starts at 64, and it works all the way through, and it finds that 11 is the smallest one, and it moves it to the top, and it moves 64 to that spot. Then it stops there. It doesn't look at 11 anymore, and now it goes to 25. It looks for the fast digits, and it looks for the smallest one here. It finds it at 12 and swaps 12 and 25. Now I have the 11 and 12 in order because 12 is the smallest one in this one here. Then it starts at 25. It looks for the smallest one. It finds 22, swaps it. Those three are now in order. Looks through 25 and 64. 25 is the smallest. It doesn't need to move. Therefore, the entire array is now sorted. So take a few moments, rework the code that you have, save it as selection sort before you begin so you maintain a good copy of bubble sort, and use the selection sort. Try to code it. Be sure you have both sorts saved under different file names. So take a few minutes to try that, and then I'll show you a solution. Alrighty, here is the solution. I think I'm going to cut and paste this into Liberty. This is my bubble sort right here. Oh, so I'm just going to put it all right in between those two. Should work. There's the unsorted array, and hopefully that sorted it for us, and it did. So let's just have a look at this code and see how this works. Okay, so once again, we've got the very top here. This is just setting up an array, random numbers here from 1 to 100. Okay, and then here's where the actual sorting code starts. I'm going to call something called marker is equal to 1, and I'm going to set the smallest value to 101. We set it equal to 101 because we know that this particular array has numbers 1 to 100, so I'm going to set my smallest one to equal something bigger than that to begin with. I set up a loop, and I go for x is equal to marker to 20. Marker is starting at 1 because that's the first spot that I have to check. And then if the current value in the array, if number sub x is less than the smallest, which is 101, then set smallest equal to number sub x. In other words, it finds, this is finding the smallest value, okay? And I also have to records the smallest position, which is important as well because we want to know where it was. Okay, and I continue the entire loop here for x equals marker to 20. I continue looking for the entire loop to see which is the smallest one. When I'm done this x right here, then I should have the smallest value. And then I set the number smallest position equal to number sub marker. So marker is the first time through the loop is equal to 1. So I find the smallest position, okay, and I replace it with the one from the start, and then I replace the marker position, which is the start one, equal to the smallest value that I found. Okay, this is doing that switcheroo here. I don't need 3 lines because I've actually, my third line is the smallest one here. So smallest is my temporary variable for the time being. And then I set marker equal to marker plus 1. I bump one more down the loop, down the array, and I reset my smallest equal to 101. Very important because you need to find the next smallest one. Because you're not going to find anything smaller than the very smallest one. And I'm going to do this until marker is equal to 20, until I get to the end of the array. That's my code right there. If you didn't get a chance to try it on your own, you should type that in and make sure you understand how that works. Pause right now for the video and type that in, or look